Hi, everybody. Today we're going to talk about graphing and particularly graphing with two variables now, or at least in two dimensions. So what we're going to look at today is the rectangular coordinate system and paired data. Now, those are pretty heavy words, but they're really not as bad as they sound. So for instance, paired data, we often think of as points. And what you're going to notice today is our points tend to be given in the form x comma y. So there is a pair of data, right? So a pair is two, so that's why you have two values here, and they go together. And they're going to form a point that we're able to graph in a plane. Now, your rectangular coordinate system has lots of names as well. So sometimes we'll just call it the rectangular plane. Or sometimes you'll also hear the Cartesian plane or system as well, for Rene Descartes. So there's different words here that you may have heard already too. So I want to do a lot of definitions today and then a lot of examples of plotting points and finding points and all of that good stuff too. Okay. So first, a plane is a flat surface that extends indefinitely, so forever. So it's going to continue forever in all directions, but we are in a plane, so we are in two dimensions. So we're talking about flat surfaces here. So you really want to think about two dimensions, not 3 dimensions, right? So we're not 3D. So just kind of as a little bit of review, we've seen number lines before, right? That looks like this. So this is one-dimensional, so it has one dimension. And what we're going to be looking at today is our plane, which basically says to put together two number lines. And we're going to create something in two dimensions. And I am going to blow this graph up and talk more about it. But I just want you to kind of see how we went from one number line, which is just one dimension. So one direction, again, totally flat. Now we have two directions here, right? We're doing a left to right direction and a north to south direction, up and down. It's still flat though, so we're not in 3 dimensions. It's not a 3D object. So it's still flat, and this is a plane. So we're putting these two number lines together, so now I have two dimensions. Not only do I have a left to right idea, but I also have a down and up idea. So this is where we're going today. And to do that, you do need to have two variables here for us to graph. So in the past, we've kind of solved equations and focused on graphing with things that have one variable in particular, or just kind of looking at some general examples. And now we're going to be looking at particularly two variables. And what we're going to notice with each of our points is we're always going to set our points up with the x value first and the y value second, where your x value is the horizontal axis that runs left to right, and your y value is the axis that runs up and down here. Okay. So I think what I'm going to do is I just want to go to the next page and just kind of blow up this plane so we can talk about it in a little bit more detail and look at some more definitions. So I am using graph paper here because I do want to try to have lines as straight as possible. And what you can do, I'm just going to try to follow lines, but you could also obviously take out a ruler here. So I'm just going to go kind of straight down the center here. And I'm going to go left to right. So we can use different variables, and you actually can swap the variables as well. But typically, so I would say like 90% of the time, what happens is you end up having the x variable on the horizontal axis and the y variable represented on the vertical or up and down axis. Now, again, you can change your variables because we have seen examples where we'll use like n instead, or maybe other letters like A or B, etc. So you can use different variables, but again, for particularly beginning examples, we tend to use X and Y. And you'll see that the X-axis is going to run horizontally and the Y-axis is going to run vertically. So this here is called your X-axis. And this one here is called your Y-axis. And that's the actual line, the number line that runs. For our X-axis, what you're going to see is that you're going to have positive values on the right. And you're going to have your negative values on the left. And then for your Y-axis, you have positive values running up. And you have negative values running down. So this one here is going to be -1, -2, 3, so on. So all we're really doing is putting two number lines together here. And then what happens is in the center, you do have the value of 0 running in both directions. Okay, so those two axes meet at 0. So you have 0 horizontally and you have 0 vertically going on as well there. So this point here, I'm going to use a different color here, right in the center. Okay, so that point there, that is the point 0, 0, and we call it the origin. So if you think about the word origin, it's usually your starting point, right? So that kind of 0, 0 is sort of our starting point where the positives come out on the right and up and the negatives come out on the left and down from there. So that is called your origin. We also, if you notice, you can kind of see that the plane is broken up into 4 pieces, right? So you have like one square here, 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 and here. These are called quadrants. So this would be quadrant 1. This is called quadrant 2. This one is quadrant 3, and we typically use Roman numerals here. And this is quadrant 4. Okay, so again, I am using Roman numerals, which is standard notation. So that is 1, 2, 3, and this here is 4. So it's like a 1 kind of like with a V. So that stands for 4 here. Now, the terms for the quadrants are really just used for us to talk about the different areas of the graph, just to make it a little bit easier. So I could say something like, hey, let's look at quadrant 1, and you kind of know to look at this part of the graph. Or I could say, hey, let's look at quadrant 3, and you know to look at this part of the graph. That's really all the quadrants are used for. They don't really have a major purpose except for to help direct our attention to certain parts of the plane. And then what's going to happen too is these numbers could keep extending for as long as I wanted to. So I could keep writing these forever and ever and ever. I just have the first few values here. You also have all the values in between. So just like on the number line, you have your fractions and your decimals there. So for instance, something like 1.5 on the x-axis would be halfway between the 1 and the 2. So you would just do your best to estimate that value if you needed to find fraction or decimal values here as well. All right, let's use a different color. So what I mentioned before is we do have what are called points, or more formally we call these ordered, look, I'm writing points, ordered pairs or points. And like I said before, we're typically of the form x comma y, so they give you this axis first and then this axis second. Your x-axis is typically called your independent axis, and then your y-axis is typically your dependent axis, just as a little side note there. So as you get into more advanced classes, we don't always use x's and y's. We may use different variables. So that way we'll often refer to as the independent and dependent axis instead. Okay, but you always have the horizontal value first and the vertical value second. Okay, so this first one here is called your x value or your x coordinate. And then the y one is called your y value or y coordinate. Now, there are other terms that we sometimes use as well here, but those tend to be the main ones. So you'll see, again, a lot of interchanging between the use of words like order pairs versus points, or x value versus x coordinate, and so on. So they do tend to be used interchangeably, so you just want to recognize both forms. All right, so let's actually practice plotting some points here. So I want to plot some points. So let's plot some points. Let's do 1, 4. Let's do -5, 2. -3, -1. And how about 8, -3. And then I do also want to do a couple others that are more complicated. So let's start with these 4 first. So our first one is 1, 4. You want to always remember that they're giving you the x value first and the y value second. So each of these pairs here corresponds to 1 point. Okay, so it's a single point, not 2 points. So what you do is you find the x and the y values, and then you're going to match them up and put the point there. So our x value is at +1. So usually we kind of start at the center here at 0, 0. We go to +1 first on the x-axis, and then I have my y-axis is at +4. So +4 on the y-axis is up here. And what you're going to do is you're going to put the point right where those two lines meet. So they would meet, notice, right here. Okay. So if I look, I'm just going to use a little pencil here to show you. You can see that going this way, right, it lines up with the 1 on the x-axis. And going this way, it lines up with the 4 on the y-axis. So that point is really that intersection of those two values. So here's the point 1, 4. Now let's do -5, 2. Again, the x value is first. So you're going to go back to your x-axis. We're going to find -5, which is on the left. And then our y value is 2. So 2 is positive, so it's going to be up here. And again, I'm going to draw that point where those two values intersect. So if I look on the x-axis, I'm just drawing using a pencil here because I don't actually want to make a real mark. I can see that it matches with -5. And then if I look on the y-axis, I see that it matches with 2. So again, I don't really need these lines in there. I'm just kind of using that to show you how they match. And then that's our final point. Let's do -3, -1. So our x value is -3. Now our y value here is -1. So we're going down 1, right? It's right here on the on the y-axis, excuse me. It's a little hard to read, but the -1 is at that first line. So it's going to be right here. So that's -3, -1. And again, you can see it matches up in both directions. And then I want +8, -3. So my x value is +8. My y value is -3. So I'm going to go ahead and match those up. So I wanted to graph 1 point in each of the quadrants for you so you could see. So here you can see in quadrant 1, all your values are positive, right? Your x and your y are all positive. In quadrant 2, your y value is still positive, but your x value is negative. In quadrant 3, you're going to notice that your x values are negative and your y values are negative. And then in quadrant 4, you're going to notice your x values are positive, but your y values are negative. So you do have some patterns there that we recognize with our different quadrants. So for instance, here, you're going to have positive x, positive y. Here, you're going to have negative x, positive y. Here, you would have a negative x and a negative y. And then here, you would have a positive x and a negative y. So just a little kind of hint there if you're getting stuck on where to look. There are patterns to each of these quadrants. I do want to plot a few more points. All right, I'm just going to write them over here. So let's plot -6, 0. 0, 7, 4, 0, and 0, -3. I'm just going to do these in green just to see some different colors here and to showcase these. Now you're going to notice here that these are still points, but each of them has a 0. So what happens when you have a 0 is that your point is going to lie on at least one of the axes instead. So here, notice that again, you're still xy. So our x value is -6, which is way over here. But the y value is 0. So if your y value is 0, we're not going to move up and we're not going to move down. We're going to stay right on that axis. So here is that point -6, 0. Now our next point, 0, 7. Now our x value is 0. So what happens is 0 is right here, right? For the x-axis is right in that center. So you're going to stay in the center. You're not going to move right or left. And then our y is +7. So we're going to move up here to +7. Okay, our next one is 4, 0. So our x value is 4, which is over here. And because our y value is 0, we're going to stay on the axis. And then for our last one, we're at 0, -3. Now our x value is 0, so we're right in the center. And our y value is -3, so we're going to move down to -3. So here are 4 examples where your points lie on the axes. And I do want to point out that if a point lies on an axis, it's actually not in a quadrant, it's on the axis. So 4, 0 and -6, 0 would be on the x-axis, and 0, 7 and 0, -3 are on the y-axis. So they're not actually in the quadrant. The quadrant is actually like in the center or in between the axes. All right, and let's just do a couple more. So what if you have something like a decimal, or what if you have something like a fraction? So maybe I have something like 7.5, 5.1, right? Now, if I'm graphing by hand, I'm just going to do my best to estimate. So my x value comes first, my y is second. So my x value is 7.5, so that's 7.5. So it's like right in between the 7 and the 8. And then my y value is 5.1. So here's 5, and 5.1 would be a little bit more than that. So I'm going to try to stay in the center here, and I'm just going to try to go a little bit above 5. So if you notice here, I'm a little above 5, and I'm right about half of 7. So we can still do our decimals and our fractions, but we're just going to have to estimate them. All right, and let's do one more. Maybe I have negative. We'll do -7.5 this time. And then how about -2.5? So my x value is -7.5 this time. So I'm going over here. Here's -7. So it's going to be a little bit beyond that. And then I'm going down -2.5. So here's -2, here's -3. I'm going to be halfway in between. So I'm kind of trying to match up with both of them. So there's -7.5. There's -2.5. Now, if your values are given to you as as improper fractions, I would definitely change them to mixed numbers to help you graph. It would be very difficult to try to understand, for instance, what -15 halves is. So if you're given values that are improper, I would make them a mixed number just so you can graph if you're trying to figure out where they are on the axis. And of course, one of the most important points, I didn't regraph it, is that center there of 0, 0. So both your x and your y axis are 0 here. So there's a few examples on really what the plane looks like and how you can plot different types of points. So what you always want to remember though is your points are given to you with the horizontal value first and then the vertical value second. Okay. Now, another thing I want to show you, I'm going to go to the next page here, is we don't always have to draw the entire graph if we don't want to. Sometimes, most of the time, you'll see that we do if we're just graphing just general equations or just general examples. But if I have a real application, sometimes we'll narrow it down. So for instance, if all my values are positive, we can narrow down to just the first quadrant. And this happens with real world examples. Okay. So not always, but a lot of times with real world examples, not all, there are definitely examples of negative numbers out there we've seen before, but a lot of the time, maybe not most, but a lot of the time, you may have all positive values. So you can always just narrow down to one quadrant. So sometimes if you'll say, well, I don't always see my graphs that have 4 quadrants like that. Well, a lot of times they may just narrow down just to the one that is most important. So for instance, let's say we're talking about something like, I'm going to try to fit it actually right over here. So maybe I'm looking at my spending on takeout. And I'm going to let X be the week. I'm going to let Y be my cost. So maybe for my first week, I started tracking this. Maybe I spent $50 on takeout. Maybe my second week I was tracking this. I spent $60 on takeout. Maybe my third week I said, oh, I've been spending a lot of money. I only spent $40 on takeout. And maybe my fourth week, I was really trying to save money and I spent $20 on takeout. And I'll do one more. Maybe my fifth week, I went out with my friends and I spent $70 on takeout. So here, if I look, all my values are positive. So I'm going to focus just on that first quadrant here. So I'm going to let this be my week. And I'm going to let this be my cost in dollars. We do like to give a title. So I'm going to write spending on takeout. It doesn't have to be anything fancy. So just some sort of title to my graph. And then the biggest thing here when I'm graphing is you often have a lot of choice in how you want to do your axes, but you need to make sure you're consistent, and that is the most important. So you want to watch your spacing. Now here I'm only going from 1 through 5. So I could do 1, 2, 3, 4, 5 right here, but that puts my graph so tight together. I don't have a lot of data here. So I'm actually going to spread my values out a little bit. I'm going to go every other tick mark. So I'm going to make this the number 1, this 2, 3, 4, 5, 6, 7, and 8. So notice that I know my line's a little bit off here at the end. This should be right on the line. But I'm being consistent, so I'm skipping, right? I'm skip 1, skip 2, skip 3. So even though I'm choosing to give some space here, I'm being consistent for the entire axis. So that makes it okay. And if I want to go this way, let me see, I have to go up to 70. So I'm going to see 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Looks like I have plenty of space, so maybe I'm going to go by 5s and not 10s here. So I can make this $5 and then 10, 15, 20, 25, 30, 35, 40, 45, 50. I'm going to keep going up. Okay, so I'm being very consistent. My scale on both my axes don't have to be the same. They can be different, right? Here, I'm actually going by halves, right? And then here I'm going by 5s. But point is that within the axis, we are consistent, and that is extremely, extremely important. If you're not consistent, if you're all over the place, even if it's just one little mistake, your graph won't have the right shape. So it is really important that you are consistent. So now let's graph our points. Each of these values in the table are actually a point. Use a different brighter value. So this would be the point 1, comma 50. So I find 1, I'm going to go up to 50. It's right here. And then here, this is 2, comma 60. So my horizontal value still goes first. So here's 2 going up to 60. Here I have 3, comma 40. So here's 3. And let's see, that is 3. In week 4, we only spent $20. And then in week 5, we bumped up to 70. So we went out a lot that week. So there is my graph for my spending for the first 5 weeks, let's say, of since I started tracking it. And here's an example where we focus just on the first quadrant because my values are all positive. So instead of drawing a whole huge graph and having 3 parts of the graph that are blank, sometimes we will narrow down to just one quadrant of the graph, and that's okay too. But it's going to depend on your values, right? So here, if I'm talking about spending, I'm never going to have less than $0, right? It wouldn't make sense to make money when you're spending, when you're buying takeout. So the first quadrant makes sense here, but there are lots of examples, maybe temperature, for instance, where we could have negative values. So it's not always a good idea to always defer to the first quadrant, but sometimes it can be really helpful so that if we have real world examples that focus on just the positives, we can just focus our graph a little bit better. Now, the interesting thing about points is that points are actually solutions. So when we have an equation associated with a graph, the points on the graph are solutions to the equation. And this is actually a really important idea. Now, in our first 2 examples that we were just doing, this example here, for instance, with the table of points, I didn't have an equation. I was just kind of graphing some random points on a graph, and that's totally fine. This type of graph is actually called a scatter plot. Okay, so if you're just kind of graphing, they're not random points, right? They come from somewhere, they're data. But if you're just kind of graphing a bunch of points and there's no real equation associated with them yet, that's actually just called a scatter plot. So our first 2 examples were really just scatter plots, just kind of plotting random points. But a lot of times what we're moving into is actually having an equation and wanting to graph that specific equation to see what it looks like. So when that's the case, we actually do notice that the points on the graph are solutions to the equation and vice versa. They work both ways. And the other thing you're going to notice here, we're going to be focusing on graphing in 2 variables, right? So now we have this whole idea of x and y because we have the x and the y axes on our plane. And typically, graphs of equations have infinitely many points or solutions. So there's kind of 3 really important things here as we start getting into a little bit more with graphing, and just kind of learning how to find how graphs of equations work, right? So they're very similar, but specifically those points actually are solutions to the equation, which is a really big idea. They're not just random numbers. And then also these graphs of equations have infinitely many points or solutions. So we could keep finding as many as we want to. Obviously, we're not going to do that. We're going to stop after a few points, but they do keep continuing on, typically in both directions. So, all right, let's try an example here. So is the point -1, 6 a solution to the equation 2x plus y equals 4. And I want you to think back to what we already know about solutions. We've learned about solutions. It's the same definition. So solution means that when we plug it in, so plug in the point here, we get a true statement. So that definition of solution holds true no matter how many variables you have. Even if you went to a higher level math class and you're dealing with 3 variables now, it's the same definition. You would have a point that has 3 coordinates instead, and you would plug them all in to see if you get a true statement. Is this still the same idea? So we're going to take our example here. And again, we want to be careful, right? This is our x value. This is our y value. So I'm going to replace the x with -1 here. I'm going to replace the y in the equation with 6. So notice that I'm just copying the exact equation, but replacing the x and the y. And I'm going to go ahead and simplify. So here I have -2. Here I just have 6. Well, -2 plus 6 is 4. So this is true. So yes, this is a solution. And so it is a point on the graph of the equation as well. Okay, so it does both. So if you have solutions, you have points. If you have points, you have solutions. So it's a really nice relationship we have between the visual or the graph and the algebra or the equation here. Okay, let's do another example. So here we have our equation, and we're going to determine which pairs are actually solutions. So what we're going to do each time is just going to go ahead and plug them in. And again, just remember, if you need to do this to help you, go ahead. Your first value is going to be your x value, and your second value is going to be your y value. So I'm just going to take my equation and replace that x and y. So for the first one here, my x is 0, my y is 5, and I set it equal to 5. Well, 5 is equal to 5. This is true. So yes, this is a solution. For the next one, I do the same thing, but I start over. So now my x is -5, my y is 10. Well, -5 plus 10 is 5. So again, we happen to have a true statement. This is another solution. And then for the last one, if I plug it in, 7 plus 2 equals 5. Well, 7 plus 2 is not 5, it's 9. This is false. So this is not a solution. Solution or a point. So if I have solutions, then I actually could take it to the next step, and this is where we're going, is we're going to graph these solutions because there are valid points on that graph. If something is not a solution, then it is not on the graph. So this would not be a point that we would plot. It just doesn't work for that particular equation. Now, what we've been doing so far is just sort of kind of picking points and guessing and checking, but there is a much more systematic way to actually find these solutions. And that's what we're going to do in this last set of examples here. All right, so instead of just guessing at points, we actually can complete order pairs in a systematic way so that we can always find a solution. Now remember, there are infinitely many solutions. So I actually can always start with one value and solve to find the second value that would make it correct. So that's what we're going to do here. And again, notice that in some of these examples, right, I know the x value, but my y value is a question mark. Here, again, I know the x value, but my y value is a question mark. And then last example, it's the other way around. I don't know the x value. So what you're going to do is you're going to plug in the value given, and then you're going to solve for the remaining variable. And we're going to use all the solving techniques we already know. So it's not going to end up changing here. So, okay, I'm going to go to A. Here's my original equation. I'm just going to rewrite it for a second. And I have 2 comma blank. So in this particular example, I know my x value. So what I'm going to do is I'm going to take that x value and I'm going to plug it in to my equation. So I have y equals -3 times, and my x value here is 2. And now I'm going to solve. And this one's actually pretty easy to solve, right? I just multiply. -3 times 2 is -6. So my final answer is 2 comma -6. And you can check this by plugging it back in. So here was my equation. If I plug this in, I would have -6 equals -3 times 2. And you get a true statement. Right? Let's try B. So again, my equation is y equals -3x, and my point is 0 comma blank. So in this particular example, again, I happen to have the x value. That's what I'm going to replace. Here, my x value is 0, and -3 times 0 is 0. So the point I had was my x value was 0, and now my y value is 0. You do want to be careful you're plugging things in the right order. So notice that my -2 was first here, and then my y value is -6. So it's still x comma y. Same thing here. My x value is 0, and it's the y value that I'm filling in. If I check this, I do see it's going to be true. So my y is 0, my x is 0, -3 times 0 is 0, so you do get a true statement. And let's do the last one. So now in this particular case, I have a y value instead, which is fine. So I'm going to replace the y value here. Okay. So I have -2 is my y value equals -3x. Now here I have a little bit more work. So think about how would you solve this equation? Well, I'd want to get the x by itself, and I want to get rid of that -3. So I'm going to divide both sides by -3 in order to cancel it out. So x is equal to, now the two negatives will cancel for division, and I have 2/3. So my problem here, or my solution, is going to be 2/3 comma -2. Okay. Again, you just want to make sure you're setting it up in that XY format so you're in the right order, because that does matter. And then if you want to check here, we can still do the same check. So my y value is -2, and my x value is 2/3. If you think about fractions, right, this is 3/1. So you could actually cancel first. You could simplify diagonally before you multiply, or you can multiply it out. I would get -6/3, and -6 divided by 3 is -2. So it still checks out. So this is a more systematic way of how we can find solutions rather than just kind of guessing at values and seeing what works and what doesn't work. So this is what we're going to start doing as we get into the next sets of videos. When we want to find solutions to these equations in two variables, which is also the same thing as finding points so that we can actually graph them, then we're going to start with one value and solve for the missing value. And that's going to be the strategy that we're going to use repeatedly in the next few videos.